All right, good afternoon, everyone. Mr. Espo here with my two favorite students, Anthony D. Benedetto and my assistant professor here, Ian Hudson. So we're going to start weekly question number one. Ian, why don't you be our guest reader for today? You do know how to read, right? It's question one.
Here we go. Number one, given that angle J is congruent to angle B and line segment KJ is congruent to line segment AB, what is the third congruence needed to prove that triangle JKL is congruent to triangle BAC by angle side?
Okay, Anthony, tell me what you know for sure. What did they tell us?
Alright, I know for sure that angle J and angle B are congruent.
Angle J is congruent to angle
B,
B.
yep.
Okay.
And line segment KJ is congruent to line segment AB.
KJ is congruent to AB.
Yeah.
Now, what shapes are we dealing with right here?
Rectangles. No,
We're
triangles.
dealing with triangles. So you think it makes sense for me to draw two triangles?
That'd be nice, yeah.
Okay. So I'm going to draw two, and we know that these triangles are congruent. That means they're going to have the same sizes, same segments, same angles.
Mm.
All right, what's my first triangle?
Triangle JKL.
J, K, L, and
BAC.
B, A, C. Now help me out here. What am I going to mark? How am I going to mark these angles?
Alright, well, you're gonna mark J is congruent to B, and then line segment KJ is congruent to line segment AB.
A, B. Okay.
Yeah, that's it.
And what do we need? Do we need angle,
Angle, side.
So what do we have right now? We have
We
an
have an
angle.
angle and a side.
So if I got angle K congruent to angle A, what would I have?
Angle, side, angle.
We would have angle, side, angle. We don't want that.
We want angle, side.
So what do you think I would do? And you got your choices here to help you.
We're gonna make angle L congruent to angle A. I don't know.
Angle L congruent to angle.
It says A. Oh no, you have to do angle L congruent to angle C.
There you go. See that? So
Yeah,
what
yeah.
choice is that?
3. Is that the answer?
Yep. Now, once you read through that and you drew the diagram, that wasn't that hard. You just got yourself all psyched up for nothing.
Mm.
All right, Ian, you read number 2 to us?
Here we go, Ian.
In isosceles right triangle RST, T is the right angle. What is the measure of the exterior angle at S?
Okay, so what shape are we dealing with here?
A right triangle.
All right, so I drew my right triangle right here.
Mm-hmm.
And what are my names?
RST.
So this is R,
And T is the right angle.
T,
S.
S. Okay, so what do we want here?
What is the measure of the exterior angle at
What does
S?
the word exterior mean?
Outside.
All right, so can I extend this angle right here?
Yes, you can.
Okay, we know this is 90, right?
Yes.
And do they tell us anything else?
No.
Does the word isosceles mean anything?
Yeah, it means these two are equal.
So you're saying RT
Yeah.
is congruent to TS, right?
Yeah.
So if this is 90 and it's a right triangle,
Oh, so this must be 45,
Atta
which
boy.
would make this I don't know, 180 minus 45 is the answer.
which is
Come
135.
on, calculator.
It's
135.
135.
And that's
And
the answer.
that's the answer, but I also want you to remember something right here. If you see these two angles right here, okay, see this angle right here?
Mm-hmm.
That's the outside angle.
It
The
is.
outside angle is always going to be the sum of the two angles furthest away. 90 and 45 is what?
135.
And these two are going to be supplementary because they add to
180.
attaboy. Good. All right, next one.
All right, Ian, take it away, sir.
Now we are on part 2. Explain why the following triangle cannot exist.
Okay, so I got to draw it.
Yeah. Angle AB or triangle ABC.
All right, so it might not look exactly like that, but we'll get the sides right.
Yeah.
What is AB equal to?
AB is equal to 26. BC is equal to 8. And AC is equal to 17.
So we got 26, 8, 17, and it's asking you why these cannot be the sides of a triangle?
I know it. Because if you add up the two smaller sides, they can't be over the bigger side, longer side.
17 plus 8
It's
has
equivalent
to be, it's 25,
25.
and doesn't it have to be, I don't know why it shakes all over like this. Doesn't it have to be greater than the third
It
side?
has to be greater.
26, is that true?
It's not.
That's false. There
That's
you
why
go.
it can't be.
Right there.
That's right.
So you gotta write that down.
I will write that down, Miss Espo. Want me to do it tomorrow when we watch this over again?
I want you to do it right now.
Okay. 25. She'll know. 25 what? 25 is less than
26.
26. That looks like an angle.
And now for part of your work, we're gonna send her the screencast,
Yes, we are.
okay? Now, Ian's gonna read the last one for us.
Ian, last one.
This is really, really important.
Really important.
State whether the lines represented by the equation y is equal to 1/3 x minus 1 and 3y is equal to negative x minus 2 quantity.
Okay, now look at this. What's our formula we know? Remember our slope-intercept formula?
Mm-hmm.
What's my slope in this one?
1/3.
So m equals 1/3, okay? What's the y-intercept?
3y. 3.
No, right here in this one. Isn't the y-intercept -1?
-1.
Okay, good. Now, are these two written in the same form?
Yes, they are. Except there's a 3 in front of the y.
Right, so what do?
Distribute.
Distribute to -1, okay? And I just want to state for the record, I gave you no hints on that, and neither did Ian. So what's -1 times x?
Oh my goodness, negative x.
-1x, and -1 times -2 is,
It's positive 2.
okay? Got some work to do. What are we going to do?
Now you're gonna do divided by 3. Yeah, divide to all of them, right?
Yep.
All right, so
Sum.
cross the 3 out in the first one. So that's y equals 1/3 x plus 2/3. I told you guys.
Okay, so what's the slope here?
1/3.
Isn't it -1/3?
Negative 1/3.
Now, when you compare these two slopes, if they're parallel, they're going to have the same slope, right?
Mm-hmm.
Do they have the same slope?
They do. They're both 1/3.
I don't know.
Oh, that's negative 1/3. My bad.
So if they have the same, if they don't have the same slope,
That
we
means
know
they're
they
not
can't
parallel.
be parallel.
Nope.
What do we need for them to be perpendicular? No, it's okay if you don't
You
understand.
get rid of the negative.
Well, look at this. If I said I had 2/3,
Mm-hmm.
what's the reciprocal of 2/3?
2 radical 3.
What's the reciprocal? Flip it. If you
Oh,
flip
3/2.
but in order to be perpendicular, I'd have to have the opposite or negative reciprocal. So take 1/3, flip it. What do you have?
3/1.
And negate it. Is 1/3 and -1/3 opposite reciprocals?
Yes, that is.
No.
What do you mean? Isn't it?
Look,
They're
is
opposite.
this is 1/3 and
Yeah.
that's -1/3.
Yeah.
Are they they're opposite because that's positive and that's negative,
Mhm.
negative, but are they opposite reciprocals?
No, they're not. Yes,
So look at the question. No, because you're overthinking it. If they're not parallel and they're
Mhm.
not perpendicular, then they are
neither.
neither.
Mm.
Okay? Okay, I'd like to just say that Anthony did a very good job, wouldn't you say, Ian?
I agree.
He's gonna take the same weekly tomorrow on his own for full credit. We're out. Anything you'd like to say to Mrs. Ellerhurst?